done.
Hello, so my name is Alice. I'll be presenting the progress of the system team today. So first we'll talk about the revised weight estimate, then the fuselage layout, and finally the ballast tanks. So first of all, as you can see, the weight went from 24 tons to 18 tons 747 kilos. So we obtained this by changing, first of all, the mission profile. The mission segments are now takeoff, cruise 1 of 1,000 nautical miles, then descend, tactical cruise 1 of 100 miles, landing, and then takeoff, tactical cruise of 100 nautical miles, and we accounted for landing in the worst case scenario if we had to refuel on land. So, second of all, we also changed the specific fuel consumption. We obtained a new one from the propulsion team. So we went from 14 to 12 milligram per nanosecond. We also took into account the weight of the hull. So we multiplied the empty weight by 1.1. New one. We also changed the crew weight, which is now 86 kilograms times 9. Why 86? Because we found it in the documentation of the Civil Aviation Scientific Authority, which says that 86 was an appropriate weight. And finally, the payload, now taking into consideration the 2,000 pounds of cargo, 1,000 kilos for the batteries, and 500 kilos for the rest, which is ballast tanks, generator, any pumps. We're not really sure this time. So that gave us 8 points. So we also came up with the fuselage layout. So the cockpit for one pilot is 1 meter times 1.5 times 1.75 meter. We also found a list of the avionics and estimated the volume, so we could get an estimate for the nose. We also found the volume of food and water that they would need, the volume of the life support system, which include oxygen generator, dehumidifier, carbon dioxide remover, and we also put and a lavatory next to it. We also added a walkway to go from the cockpit to the cabin. As you can see, the configuration of the seat changed from last time. Last time we used a configuration of the same as in a tank. It's now a configuration like in a plane, so they're all facing forward. We found the dimension by looking at the restriction for a civil aircraft. So we changed this configuration so that we could have more space around it to flood it. So now the total usable volume is 13 meters cubed. In the worst case scenario, we could also flood the cabin, which will give us a new volume of 7.4 meter cubed. You can see that above and under the seats we've got more space to have the gears. We looked at 2 undercarriage design concepts. We haven't chosen which one yet, but basically one, the landing gear is retracting and fuselage mounted pod, and the other one is retracting into the fuselage. So one of our main problems is to sink the plane. So we've got 3 main options: negative lift surfaces by changing the angle of attack, the underwater propulsion, and the ballast tanks. So from the system point of view, we had a look at different ballast tanks. So the first one is the gas ballast tank. It's simple, but we need to be carrying liquid gas. So because we're trying to save weight and volume, we decided not to go for this one. for the vented ballast system, the main problem is that the vent needs to be above water at all times, so it can pump water. So obviously at 30 meters deep it's not possible. The compressed air ballast tank is quite complicated and very bulky. It involves taking the air from the outside, compressing it, storing it, and then using it. So we decided to go for the pressure ballast tank, which at the beginning there is only ambient air in the tank, then the water is pumped in, so the air is compressed, so the whole thing is heavier. And then when we want to surface, we pump the water out, and the air expands and the water goes out. And then, so we decided to go for this one, and it's also the lightest. Finally, we just, when looking at the ballast tank, we found this, the recirculating compressed air ballast system, and we thought it might be useful for the fuel system, because we decided we wanted to flood the fuel tank. So we are thinking about putting something like the ballast bladder, which acts a bit like a balloon, and inflates it.
So your rationale of 86 kilos for your crew weight, is that including equipment?
No.
Is that a civil?
Yeah, that's civil.
Okay.
It's checked for the military requirements. That's not including the equipment.
So not including a standard soldier's backpack and
No.
firearm level.
No.
Okay.
That's why we count it in the 2,000 pound.
Okay. Sounds like probably not that. Can you explain why is there a factor of, what was the reason behind putting a factor of 1.1 on the whole weight?
It's 10% more for the hull. Okay. We got this from structure.
So what, okay.
So just added 10% of the anti-weight for the thickness and the material.
Okay, over what? So
Because the first method is based on a normal airplane. So obviously there's no hull.
So they predict, so someone's going to tell me why they think the hull needs to be 10% stronger in order to be a submarine as well. That's the number they've got. Okay. So back to your options for, your submersibility. So option 2, the pressure ballast tanks.
Yeah.
Are you effectively pressurizing the air inside the submarine?
You mean in the cabin or in the tank?
In the cabin?
In the cabin we are pressurizing, but as in the tank there's ambient air, and then the water compresses the air.
Okay.
And then so the what's not great with this tank is that you can only fill 70 to 80% of the tank, because the rest is compressed air. But it's so we don't have to have a pump or a compressor.
I mean, could you integrate that with the air in the cabin, or are you keeping the two systems completely separate?
I thought we were keeping it completely separate, but I don't know. Because we're planning on keeping all the ballast tank here.
Okay.
Here. So for now this is separated.
So when they're flooded, the air out of those isn't going to go into the cabin, for example?
No.
Because you need to pressurize the cabin and you need to take the air out of the ballast tanks in some configuration.
Just to add, the air remains in the ballast tank. So what happens is a high pressure pump pumps the water in, compresses the air to about 30% of the volume in the tank, and the next 70 to 80% is now filled up by the water from outside.
Yeah.
So the two systems are separate. You have the cabin, which is a pressurized vessel in itself, and then the ballast tank, which are pressurized vessels also.
So how is the cabin pressurized?
The cabin is pressurized, basically through standard rubber seals that you see in cabin of a commuter aircraft.
Okay, so as in it's isolated from the outside pressure,
Yes.
so the
Yes.
soldiers won't experience a change in pressure.
Correct.
Okay, so it's isolated.
So two observations about that. One, you've made stability's job very difficult because you've now got water sloshing around in the tanks. So underwater stability is now a very difficult problem, especially in manoeuvres, right? You're manoeuvring and you've got water sloshing over to one side. That's going to be. And two, I'm guessing you're going to need a pretty sizable pump in order to pump the water in against a sizable pressure gradient.
Yes, from preliminary
So
research.
do you think that there's actually going to be a weight saving? Because presumably you're going to need a much bigger pump.
The reason for this is not to save weight, but to create space that we can fill with water. Because the primary concern with the shrink in the cabin design from before was because we are trying to find a way to get it to submerge easily. Based on the volume of the aircraft we have and the weight, it's going to take about 10 to 15 tons of additional weight to get it to sink. So by giving it extra volume, you get the extra water in, which is the extra weight you need to sink. So yeah, that's.
No, of course you need to take water
Yeah.
on, but then my point being that you're creating a much bigger pump to physically push the water against the high pressure air.
Okay.
And then two, when you're manoeuvring underwater,
Yeah.
you've got all of this sloshing going on. It's going to be
They all have pretty big pump anyway, and all the tanks, stability told us that the tanks were not going to be filled 100% anyway, so.
The thing is, if you leave the tanks full of air, I suppose you do have to get yourself under the water first. Okay. Yeah. I suspect it wouldn't be too big a pump. Pumps are pretty-
Preliminary
pretty small.
research from what we've done. So small tanks on sail which carry about 120 liters of water weighs about, I think about 30 kilos for the pump and the tank itself. So we probably have to scale that system up or try and find something on the market. But currently we haven't been able to find something that can fill up that yet. So the other option is to use more than one tank. The plus point about having more than one tank is that for stability we can use now maybe 3 big clusters of ballast tanks, one at each end and one in the middle, plus smaller trim tanks, so that you can move the water between ballast tanks easier. You can trim out the aircraft underwater.
So what's the rationale for going to airline seats rather than benches? And you covered that.
Because we have a smaller width of the cabin, so then we have more space here.
The refreshment trolley.
From
Have you considered the trade-off between pressurising the cabin and the strength of the cabin required? So I'm going to talk about that.
Yeah, I'm
Because
gonna-
we're quite happy to take 2, 3, 4, 5 bar. Anyone who's gone diving knows that. So it's like, is there a disadvantage?
And you can save a lot of structural weight, presumably, if your differential pressure is smaller.
I might have to leave this up to structures to explain further, but I believe
What's the question? Sorry, I didn't hear that.
So you pressurise the fuselage. So essentially, when you pump water in, rather than pressurising water in some ballast tank, you pressurise the whole fuselage. So your differential pressure across the skin is lower. So you need less structural weight.
Yeah, I mean, I guess that is a possibility. Well, we considered a few options. I guess we didn't consider just pressurising it with air. What you have to bear in mind is that depressurisation often takes some time. I know that as a diver, if you're at 30 metres, for any significant period of time, it takes quite a while to depressurise yourself safely
You wouldn't want to do that. But
before you get to zero. So there's a bit of a time constraint to add.
But 5 metres or so is, you can go from 5 metres without doing yourself any damage, right?
Yeah, 5 metres is pretty
Yeah.
much safe limit as long as you're not spending like a day at 5 metres, you'll
Yeah.
be alright. So that's a possibility, yeah.
And you could keep it as a, well, maybe not. I'm going to say nitrogen-free environment, but you probably don't do that.
I believe the current arrangement between the structures
Still
between
have
us is
slide
that
it in there.
the external skin, the fuselage, the circular bit, you see, it's meant to take the pressures of the hydrostatic pressures underwater. So the skin is basically designed to take the additional forces, and the cabin is just pressure from the pressurization of the cabin.
But that's the thing, so you guys are now saying that you've got a pressurized tank so that you can actually increase the pressure on it, so that changes it. I mean, how?
Okay.
is the internal, is the fluid inside the tank that is in pressure,
Yeah.
moderate
Yes.
pressure, just what is needed to push it in. But outside there is just atmospheric air and no water possibly, otherwise you have to waterproof the whole structure. How much differential pressure are we talking about for the inner fuselage? What 1 atmosphere at most, right?
It's whatever you guys need to compress all that air, I suppose.
Yeah.
No, I mean when you're in flight, yeah. What's the pressure outside that rectangle
Half.
In the water.
in air?
Flight
Yes.
is
Yeah.
half.
that-
Right
Like-
there, high.
Yeah. With whatever pressure.
And you want 1 bar inside, so we're talking about 1 bar differential, right? Whereas when they go underwater, we're talking about more.
Yeah.
Right?
I think
3.
bar.
Is that it? Yeah.
So, yeah.
Well, the one is an axial, the other one's a crushing load. So someone's
Pressure typically is
one's a hoop stress, the other one's a crushing load.
Yeah.
Yeah.
Basically, this comes from my recommendation, I guess, because the guys came to me saying, let's make only the inner cabin waterproof, and let's let the water leak through the outer one. But I don't think it's feasible to have all the inner structure of the machine here, the vessel, potentially in contact with seawater. There will be like a huge complication in a practical. I don't know if we have to take it into account or say that okay, because it's defense, we don't care, we can do that. So I was suggesting them, let's take the outer hull to take all the hydrostatic pressure when we are at depth, and let's not worry about the inside. And seems to be working.
Yeah, it's certainly possible. When we get a better idea of the weight involved, then I imagine Aero will be able to tell us whether it's feasible to fly or not. But from a structural point of view, it's possible.
also it's also convenient. Another reason why it's also convenient to make the external skin thick to pressurize everything is that skin will also be used to carry shear from the tool, which makes it's weight that is being saved because the skin will be also needed there to prevent that. And if we also put skin on the inner cabin, it's more weight that we're not using. So we're using the same skin for the same thing.
Yeah, also one loading condition that they haven't looked at is the slapping, right, the impact.
Yeah, that will
So-
look at that when we've got a hull. to
If
work
that
with.
gives stresses of order rho CV, you guys tell me if I'm right or wrong, but it's serious stuff, so they may end up having a heavy structure anyway because of the wave slapping on the outer shell, so it seems logical to make that as the resistant part, and then inside we can play kind of safe
Now, you would expect a 25% weight increase just for the hull.
for the slap.
Yeah.